So we're just about to start the second week of economics for food nutrition policy. Welcome to my home office here. This is where I spend a disturbingly large amount of my time on email and bouncing back and forth the trunk over there, slides. But as I do economics, I realize that there's a whole lot of it that you just can't do on the keyboard and watching PowerPoint and looking at things in trunk and on the email. There's really no substitute for this, which is the old-fashioned thing of just trying to use geometry, use a pencil and paper diagram to capture the logic of economics. So what I've done here is put my trusty iPad up on a table here and show you what I hope you're doing as you watch these PowerPoint slides, taking notes for yourself to say, how can I sketch, how can I draw, how can I remember in a tactile, muscle memory kind of way what these curves are all about. And I'd like to just walk through then what the exercise for this week asks you to do, and we'll do a lot more of this throughout the semester. And it's going to take a certain amount of discipline on your part if you're used to doing stuff just on the keyboard, typing and so forth, to pick up a pen, take a big nice wad of scrap paper. Remember that term? Raid the recycling bin at your workplace, get a whole big wad of paper and go to it, because there's no substitute for just drawing these things over and over again until you really, with muscle memory, with that tactile sense, can have a physical memory of how these curves represent reality. Now remember, you could do this logic of economics in very complicated math in many dimensions. The purpose of using it of doing this class in just 2 dimensions is so that we can have it on a piece of paper, just 2 dimensions, and so that we can have it on PowerPoint slides, just 2 dimensions. We're doing a 2-dimensional slice, right? This is a piece of paper. It's a 2-dimensional slice of an infinitely dimensioned world in which we're holding all else constant. Everything that's not on this sheet of paper is held constant. No change in the temperature, the rainfall, or anything else that's happening. We're just going to project into 2 dimensions, different 2-dimensional slices, and think through the logical consequences of economics, meaning optimization by individuals who interact to come up with a predictable outcome that we call an equilibrium when each of them tries to do the best they can when they interact by whatever market rules we have. And these diagrams draw a 2-dimensional slice of this infinite dimensioned reality in only a limited number of ways. So let's just see what those kinds of diagrams are. Each diagram is a 2-dimensional slice of an infinite dimensional world. We put 1 dimension on one axis, from 0 to 1, 2, 3, 4 of something. So let's start with the first kind of diagram, which was a production possibilities frontier, where this is some kind of output. So this is perhaps the quantity of coconuts. And Robinson Crusoe on his island might be able to get 1, 2, or 3 coconuts, and if he gets 0, it's here. If he gets 1, it's here. 2, it's here. 3, it's here, and so forth. This line is a 1-dimensional slice of an infinitely dimensional world, in which, of course, there's much more than coconuts. But because we're privileged to work in 2 dimensions, we can add just 1 more dimension. And so, for the example of Robinson Crusoe, of course, we have fish. For your homework exercise, instead of fish, these are going to be bucks. And again, it might be 0, 1, 2, 3, and so on, more. And if they had just no fish at all, it would be 0. If they had 1 fish, 2, and 3, and so forth. And the logic of economics begins with any old observation. So we might land on this island with a clipboard, interview Robinson Crusoe, and we would find that, I'll just close my eyes and drop my pen here at random, it just turns out that he happened to have 3, 4, 5, 6, 7 units of coconuts and 3, 4, 5, 6, 7, 8, 9 units of fish. Now notice the point is that this is whatever I happened to have found when I approached him with my clipboard and saw that he had 7 coconuts and 9 fish produced over a day or a week or a month. And my logic of economics tells me a few things about what else would be possible. That production possibilities frontier from the logic of economics has to extend from this point in this direction or in this direction. And every time you think about these problems in the context of our economics class, I hope you'll go back to the slides and just scroll up through the PowerPoint or fast forward through the video to get to the place in the slides where we first explain this idea. Of course, you can also go back to the economics primer that you did online, and you can go to the physical textbook if you prefer to read it on paper. However you like to see this stuff, it's the same stuff described in different voices, different ways. The basic idea being that anything that is to the left of this point would be equally possible, and anything to the right down here would be perhaps equally possible as well. But something here in this space would be unambiguously worse, so an optimizing person wouldn't have chosen it. Anything up here would have been unambiguously better, so an optimizing person would have chosen that instead of this. If we observed this, it has to be true that other options that are equally possible would have to be on a curve like this. We know that this curve could go in varying shapes, but it must always slope down. In the particular exercise, I ask you to draw at least 3 points, so it could be, for example, one here, and one here. And you can then link them in a straight line. You could link them in a curved line. If you had more information, if you don't have any other information, then the straight line is what you'd want to do. So you could imagine drawing many kinds of production possibility frontiers of this type. These might be for an individual. If we had many individuals, we would simply have many times this. So it would be perhaps 7,000 coconuts out here, and perhaps 9,000 fish up here, and it would just be a much, much larger curve of this type. Now, once we turn to prices, we might still have quantity of coconuts here, and you'll see from my handwriting why it is that I like to type so much. But here we would have the price of coconuts. Now, we could again appear in a place with our clipboard and observe what is the quantity of coconuts. And remember, this is going to be for some particular place, some particular time, some particular type of coconut, and some particular number of people in that place. So it could be, if I'm doing tomatoes at a farmer's market in Massachusetts, it would be the quantity of tomatoes in my hometown, Somerville Farmer's Market. We have Wednesday and Saturday farmers, so it would be Wednesday farmers market in Somerville, but here it could be quantity of coconuts on an island in a year. And here the price might be whatever it is, and if we just simply observe some point at random, and the quantities don't matter here because this is pure logic, whatever that quantity is, quantity of coconuts, whatever this price is, it must be true that at a higher price, the sellers would sell more. Now, we don't know how much more, but this curve has to be upward sloping, and similarly at a lower price, they would sell less. So this supply of coconuts curve has to be upward sloping simply because our production possibilities frontier is going to be eventually bowed out at the points of choice. And the reason why it's bowed out at the points of choice had to do with why a person would have chosen a point along here. And at this point you will say, well, I don't remember why they chose a point along here, and I'd ask you to go back to the slides just keep scrolling back through the slides, either in the video or in your textbook, or the comparable things, material in your textbook, to say, well, why would they be anywhere along this Prussian possibilities frontier? If you do that, you would see that their choice to be here or here or here depends on which is most profitable or gives the highest revenue. And we, if you recall, captured revenue, or the amount that a person might get from fish and coconuts when you add apples and oranges or fish and coconuts together. You need some way to compare them, some way to take the apples and the oranges and say, what do they add up to? We conventionally, in our wallets and bank accounts, do that with dollars, but Robinson Crusoe on his island might do it with cowrie shells. People in other countries would do it in other currencies. It doesn't make any difference what the price is measured in, but everything would have a value in terms of some price, and that price of coconuts times the quantity of coconuts plus the price of fish times the quantity of fish, here where I'm multiplying each one and adding them up, gives me the total value of the coconuts and the fish in terms of dollars or drachma or pesos or whatever I'm adding up in. And I can turn this concept into a line on this two-dimensional, remember it's just a two-dimensional slice of an infinite dimension world. I'm going to turn this idea into a picture geometrically that's going to capture the logic of a farmer trying to do the best they can. That is to say, to get the most out of all their coconuts and fish. And at this point, you're going to say, well, I don't remember how that happened, and I would ask you to just go back in the slides all the way back to where this idea first came from and redo the little bit of algebra that led to the idea that that a line representing this same equation is the quantity of fish, and I'll just abbreviate QF, is equal to, now I've got to remember and do it right, is hard because I'm doing it on the fly here, but is equal to the revenue level divided by the price of fish. So that's revenue divided by the price of fish, which is, if you think about the arithmetic for a little bit, is the quantity of fish that you'd get if you had no coconuts at all. It's just revenue in terms of fish, minus the price of coconuts divided by the price of fish times the quantity of coconuts. So this ratio, the price of what's on the x-axis over the price of what's on the y-axis, gives us the slope of a line which has a negative slope that is flatter if the price of fish is higher, so that this ratio is a smaller number and a flatter line. So as the price of fish gets higher, this line gets flatter, and the farmer, our prediction about their behavior, if we're an economist, is that the farmer, or the Robinson Crusoe character, would like to have the most revenue possible. So the most revenue possible is where revenue divided by the price of fish is as high as possible up this line. In other words, the line whose slope is that, negative price of coconuts over the price of fish, that line should be as high as possible, to have as high a revenue level as possible. So you can see that if the price of coconuts over the price of fish was a very low number, a flat slope, then this one might be best to go out and catch only fish, because coconuts might be very, very low value. I just don't care about coconuts, so I just get fish. But if the price of fish were to fall or the price of coconuts were to rise, so this ratio becomes a larger number and this line becomes steeper, then I might switch to that point. And if it becomes very steep, I might switch to that point. And you'd want to recall then how this worked on the slides. You can look at how it works on the in the textbook, and you can also, of course, come to office hours, and we'll draw this on the virtual whiteboard in the Adobe Connect software. But the point is that these lines show revenue, and I might, under different circumstances, have a blue revenue line, or even perhaps a green revenue line. And each of those different circumstances would lead me to choose a different point along here, whereas the price of coconuts here gets higher, so this ratio becomes a larger number and this slope becomes steeper, I would go from no coconuts as the price of coconuts becomes higher and this line becomes steeper, to more coconuts, to even more coconuts. And so when I take this other dimensional slice of the world, the same x-axis you see, but a different y-axis, now price of coconuts, I'm always going to have a higher price of coconuts getting me more coconuts. In this two-dimensional slice, it's at the expense of fish, but in some other dimensional slice, getting more coconuts from a higher price of coconuts might come from more effort, more work. It might come from less other things I might do, like Robinson Crusoe might be playing music or making clothing for himself, and the higher the price of coconuts, the more coconuts he would make. It would come at the expense of the music and at the expense of the clothing he's making for himself. So I'll stop there, just having gotten a supply curve. We'll take this up next and look at demand.